I want to talk about ingest decision, right? That records our errors and audit and stuff like that, right? So last we talked about this our bouncer, our gatekeeper, right? That make sure that we have an at least a good order in our job queues, right? And so, when we were talking about that, we actually made mention of some things like, um, so we made mention of this decision record as something that actually gives us access to store our errors or our success messages. So we created a DB that records such information for us, and so we want to see the DB itself, the construction or the code of this. So this is I'm building a PostgreSQL. Um, is a background checker or sorry background worker, right? And I I uh, shall when we continue on this now, explain more about some of the things, right? Um so these are the crates we are using, right? And so this is just a day, right, that gives us access to store value. So this is a generic type that can store an object, a string, an array, or whatever, right? Then this DB actually gives us access to store to this DB. This is the DB library, and so this actually um, connects um, gives us a connection pool, right, to our DB. So that's what it does. And so what happens in this is that when we query, when we run a query, right, the SQL um, needs to borrow our connection pool, right? And for you to be able to run and do all the necessary things you need to do, right? When that happens, it have to return, right? You have to return this to the original owner, the pool to the original owner, and um, this it gives us that flexibility of not actually calling this in everywhere, right? We have one source of truth that everything is actually um, moving through, right? And so this struct is what um, holds our or stores our DB, right? And so this is taking ownership of this, and it's taking ownership of this. That's basically what is happening here. Mm, so this is the moment things actually start becoming much more interesting, right? So this is the writer, right, that writes to our database, right? And this is actually borrowing the repo, right? The repo you created. Instead of just trying to own it or trying to consume that repo, which is not really necessary, because why this gives us that advantage so that we will not have that, we will not be creating connection everywhere, right? So we just created a new one here, and we just need to just borrow it and do whatever you want to do with it, right? So um, these are our parameters, right? And these parameters are they have different data type, and so this is where our SADA comes into play, right? And so this function here is returning an ID, right? This a unique ID. So this unique ID is something that we can use to query or to link. or to actually fetch any information you want to fetch later on our DB, right? And so this either returns an ID for us or actually an error if anything goes wrong. So we allowed Ross to create this unique ID for us, right, and not PostgreSQL to create it for us. And the reason behind this is because is a bit straightforward and is easier to return immediately, right, than allowing DB to do the return for us. If you do the return for us, you have to insert the return and the ID, right? And it's just a bit, it's much more easier to return the value, right? To return the ID from Rust than that's why we allowed Rust to create it. And also, I mean, you can DB can still create this thing for us. DB can still create this um ID for us, right? And so this is where things start becoming interesting. So this is us trying to create a DB. So to create a database that have um, these rows, right? And so these parameters are linked to this, right? They are there are parameter values that you use to attach these informations, right? And so what we are trying to do is to get access to the unique ID. Remember, when the information is passed, there's a unique ID and there's a time frame, and there is also what is it called? So the two things we passed here is two things we passed here um is just I think the the rate limiter and um so what we did there is the queue and the timer and the count. That's what we inserted there. That's what we tried to um query, or that's what we try to insert into our PostgreSQL. So this is just the guide that allows us to have access to DB. It gives the queues, right? It gives queues access to the DB, like I explained in my previous video. So, and just minimize um, um, the load and also rate limiting, right? Um, so what this is doing is just that it's trying to help store these informations, right? It's creating a rule for us, right? It's creating rules for us, and this rule will contain an ID, right? The query name, the queue name, right? And the decision we have in hand. Because, um, for instance, so why I'm focusing on this guide is because that's the first thing we've explained, right? So, for instance, the guide will tell us, okay, this is not allowed because we have exceeded the limit of 10,000 queues, right? So, this is to give us the queue name and the decisions and the reason code, and then give us a detail, right? And so these details, this thing now is um what we really try to insert here, and this is what we really try to insert here. And so we are executing this actually into this place. So we are not really expecting any return value. We are not expecting anything, right? We are not expecting any value to be returned. The only thing we are expecting in this is you're not expecting any row. You're not expecting SQL to return any row for you. What we're expecting to return is just an ID, the ID of that row, the ID of the row. That's what we expected to be returned, which can be valuable when maybe you want to do linking or um, access it any other time, right? That's um that's why returning this ID is actually important for us, right? And so this is just everything. If everything goes through fine, if there is an error somewhere, then return the error message. So um, what this information is doing for us here, this gives us access to filter, right? Filter using a unique using a queue name, right? Or not filtering. So example, maybe you want to filter this message, the DB, right? You want to have access to only one queue name, not everything on the DB, right? We can actually filter, or we can just query um all the list in our decision table, right? And so this actually gives us access to filter. So this queue, this queue is saying that is either we are returning a string, that is this queue, if the provider provides a queue name on this, right, return just that queue name with the details, right? If not, if none, if the user didn't provide anything, right, just return the full um DB list, right, of the um denial and allowed um, information, right? And now this needs a limit. You're not expected to maybe try to bring all the list or the whole um, um, you're not expected to query everything from the DB, right? Or the whole table, or the whole rows from the DB. It's not doesn't really make sense, right? So it gives the user a limit to maybe how many the user wants to query, right, at the end of the day. And so this is returning a tuple, right? And this tuple has this is just giving us a quick access, right? A struct would have been much more better in this setting than tuples, right? But this is just the first approach that came to my mind to use, so I use it. But a struct would have been better, right? Because there might be a lot of um, errors here and there, and mismatch here and there at the end of the day, right? Um, because these values are sitting next to each other, right? So tuples return a bag of values, why struct is more labeled, right? And so yeah, that's just it. So this is expected to return a vector of value. So when the user queries, so this is what is expected to be returned, right? So and the user can either query via filter, or try to actually query all the whole um, table, right? And those table has should have limits, right, to what they can actually access at a time. And so this is just saying if the user actually provides a unique ID, just list these things, right? So now what this query as actually helps us to map return value into a specific rows type, right? So that's what this thing gives us access to, right? It helps us to map our return values into this, right? Like return rows into a specific. So these are the rows that needed to be returned, right? So this as helps us to map it out to what we really need specifically, right? Uh, And so here, what we are saying is just that we need a specific ID. We are not trying to fetch the whole information here. What we are looking for is we are looking for a unique a specific queue, right? And this specific queue should also have a limit, right? You're not trying to fetch everything about the whole table of queue. Let's say we have like 20,000 queue, let's say webhook, right? We have 20,000 webhook information in our DB. We shouldn't actually provide everything at once, you know. it should have a limit of okay what you can really access at the time, right? And this gives us access to fetch all of our information. So fetch all and run the executable inside this PostgreSQL. But the limit is also part of what we also integrate so that you don't do more than you need to at the end of the day. All right. And so this binds this to this and this to this, right? Um, so now this is more like if there is nothing, if there is nothing, right? If the user didn't provide any filter, just query all the information in the DB, but we are still specific about the limits we can go at the time, right? And so at the end of the day, no matter which aspect, we are still expecting a role, right? We are expecting rows of the information we queried at the end of the day. And so basically what this is basically what this thing is doing, right? And so why we decided to follow this route is because um um let's say why you wanted to follow this process and not using logs like logs is because logs are temporal and is messy, right? And it can be lost, right? Information on logs can be lost, and the querying is not really consistent, right? It's hard to be consistent at the end of the day, right? But with this way you can really ask questions like you can query information like Postgres. You can ask PostgreSQL, right? Questions like maybe show me the last 200 denials, right? Or which queue hits a rate limit in most. It may be webhooks, it might be email, whatever, right? Right. And what payload size are being rejected, right? And when did the use starts happening? Like it gives you information you can relate with and you can filter and relate with normally. Um, yeah, there's another thing I wanted to talk about. This denial or access of a thing. So here, the decision here should be is either is access or denial, right? And we are expecting a string, right? On a normal, this this can actually be an error over time, and it will make our information not to be reliable and explainable like that. Because some people can query, let's say, um, maybe allowed or deny that have maybe lowercase and not uppercase, or allowed that have mixture of upper and lowercase, right? And at the end of the day, you find out that it is not consistent, right? And so there are also better ways to handle this. Is either um, we use an enum inside our database, which has some trade-offs here and there, right? But I think the better way to handle this for us is to use this string and also use a constraint, right? To be able to handle and a check constraint to be able to handle and check what we need. And what we're actually looking for is either this is denied or allowed, right? And so yeah, that's basically what this thing is. This is just a very basic rundown of what is happening here, and yeah.